In software quality assurance, we are taking the multiple choice questions. What is the difference between quality assurance, quality control, and testing? So in the software field, you can understand it with this picture. There are three hierarchy levels. Then you see here the lowest one is testing, which is inside quality control and which is inside quality assurance. So testing is all about finding the problem defect in the product. Quality control is evaluating the quality. That is, we are trying to estimate whether our function, our product is meeting the customer requirement and customer expectation. Quality assurance is defining and improving the quality related to the different processes which are followed and the procedures which are followed in the organization or in the team to ensure the quality. So this is the biggest main set in which quality control is there, for which the testing is a part. So quality assurance is the process of planning and defining the way of monitoring and implementing the quality processes within the team and organization. So please understand, quality assurance is a management concept. So this method defines and sets what are the quality standards the organization has to follow and eventually the projects have to follow. Then comes the quality control. Now quality control, here we try to find out the defects, the problem, and then we try to provide the suggestion to improve the quality of the software. So we are controlling the quality here. So we need to know the quality first. So method used by quality control, these are usually established by the quality assurance, that the bigger part. And this is the responsibility of the testing team to implement the quality control. Sometimes there is a separate quality control group which sees that. Now coming to the testing. Testing is the process of finding the defects, bugs and problem. So it actually validates whether the software product which we have built meets the requirement of the user or not, and also the standards which are laid down by the organization as a whole. So main focus is bug fixing. What do you think quality assurance activities should start? Now, this can start anywhere, but the best part is that it should start at the beginning. So whenever your project is at inception, the QA activity should start at the beginning of the project, quality assurance. The more early it starts, it will be beneficial for achieving the quality. What is the difference between the test plan and test strategy? So test plan comes under the test strategy. So test strategy is a bigger set and test plan comes under this test strategy. The test plan actually implements this test strategy. So test strategy is a high level document describing the way testing has to be carried out. And test plan, the documents you can say they derive from SRS, describing the scope of test and all the activities which you need to perform in order to test your software product or the specification or the design, etc. So test strategy is at the higher level, and mostly it is created by the higher level authority like the project manager, which demonstrate the overall approach of the testing for the entire project, what needs to be followed. While the test plan, it depicts how the testing should be performed for a particular application falling under a project. Can you explain the software testing lifecycle? So we already know the software development lifecycle, SDLC. We start with the requirement gathering, then we do the requirement analysis, then we design the software, and then we code actual programming, then we test it, and finally we deploy it. So this is the SDLC process. Now in STLC, now we are talking about the testing life cycle. So STLC is software testing life cycle. Now this STLC is referring to the testing process that has specific steps to be executed in a definite sequence in order to ensure that the quality goals have been met. So software testing under whole life cycle, that we are testing and trying to find out and ensuring the quality goals are being ensured and met. This is how it is done: test planning, test design, test execution, test closure. How do you define a format of writing a good test case? So a good test case is that test case which can find a bug or a problem or a defect. Okay. So this is the one line answer. But when you're talking about a format of a good test case, it should, depict all the information. So we have a sample here, and you see the format of the test case should include the test case ID. This you see here, test case ID and test case description. Sometimes you need to give the severity also, the test priority also, whether it is high, moderate or low. Then the environment, this is also given, the build version and the steps to execute. These are the actions. And then the two things very important: what is the expected output or result, and what is the actual output you are getting. So this will show the difference, and that will show that, oh, testing is successful or not. So this is a kind of good test case. What is a good test case? Again, testing is done with an intent to find an error. So if you are making a good test case, it should give you some error. So a good test case should have a high probability of detecting, finding the errors. High probability. The test case which is just written without any probability of finding error is not a good test case. Then the test case should be limited. That is, it should cover whole equivalent class. That is, say 1000 line of code is there, and if a test case can test 500 lines, no better than that test case. So it should cover the additional test case possibilities also. Let me show you here. A test case has to be simple, understandable everyone. You keep in mind the user always. Don't repeat test cases, that is redundancy should be avoided. Do not just assume, see the concept, design and then do it. You need to ensure 100% coverage. It should be identifiable. Use different testing techniques which are laid down and which are the industry standards, and the self-cleaning, the repeatability, you can apply it anywhere also. And the test cases should also be tested. There has to be a peer review. So this is what a good test case encompasses. So what is a good test case? Again, when you make it, it should find out an error. So all these are the underlying facts which, when you are making a test case, error should be found out. But you don't waste your time in making too many test cases. There are equivalent partitioning, there are different boundary value analysis, there are different ways of actually making good test case that covers the most of the coverage part. Okay, so the good test case, let me show you here one more concept here. A good test case is one that finds a defect. This is a simple way of answering this kind of question. But all test case will not find defects. So a good test case can also be one which has all the prescribed details. What would you do if you have a large suite to execute in very less time? Now there can be various ways. The first thing is there is some pressure. You have say 1000 test cases. Now you can only say test 100. So what do? First you have to prioritize it. That which test case is important, which test case is not that important. So priority has to be given. And then first you do the highest priority test cases. Then we can make sure that important aspects or the functionalities have been tested. Or you can go to the customer and you can ask, okay, which of the functionality is important to you. Use those test cases which test those functionality. Do you think quality analyst or quality assurance can also, basically we're talking about analyst here, can also participate to resolve the production issues? So a quality analyst, he can also do this work, because the idea which he gets from here can be utilized somewhere else. This will be a good learning curve for a quality analyst to participate in order to resolve the production issues, because various times the production issues can be resolved just by clearing the log or just changing the registry settings or even restarting the service. So these kinds of environmental issues could be very well fixed by the quality assurance team and QA team and quality analyst. So if QA has insight into resolving the production issues, this can be included in the test cases, and that will improve the quality and minimize the production defects. Suppose you find a bug in production, how do you make sure that the same bug is not introduced again? The simple thing is to catch that test case and use it every time. This is the best way, and that is where the regression testing comes under. Regression testing is all about when you change somewhere and any kind of inadvertent effect should be seen. So when we have a test case in regression testing, there are different ways. There is a test case set, so we take those test cases which are important to test this particular change where it has been made. So the best way is to immediately write a test case for the production defect and include it in your regression test suite. This will ensure that the bugs does not get introduced again. So we retest all we can do, we prioritize in regression testing, we take the subset of the test, the bigger set of test cases. So we think of alternate test cases or similar kind of test cases and include them in our planned execution. So this is how that bug will not be introduced again. What is the difference between functional and non-functional testing? So whenever you work on the software, somebody is working on the software and the requirements are there, the use cases are there, those need to be fulfilled. So that use cases requirement, are they fulfilled or not, executing them is the functional testing. That is, and for example, those which are not being specifically said but it should be there. For example, 10 GB file transfer you're doing, and the functional testing, oh, the file transfer is taking place. But non-functional testing this is taking a lot more time than we would have expected. This is non-functional testing. So in functional testing, there are various kinds of testing: unit testing, integration testing, user acceptance testing, all these are there. In non-functional, we use the load, usability, scalability. We'll talk about stress also in the later discussions. I'll come to one by one comparison. Before that, functional testing is dealing with the functional aspect of your application. So this test that the system is behaving as per the SRS, software required specification, and these are directly linked with the customer requirement, because there you will have the use cases. We validate the test case against the specific requirement and make the test result to pass or fail according to the user requirement which is there in the SRS or the specification or the requirement. So regression, integration, system smoke we do here. In the non-functional, the tests are non-functional. It does not focus on the requirement, but the environmental factor and the perceivable factor like the performance, load and stress. Sometimes they are not explicitly specified in the requirement, but they are prescribed in the quality standard. So a QA, in this quality assurance, we have to make sure that the priority and sufficient time has been given to all these non-functional testing, because non-functional requirements are generally not that much you will find in SRS. So now let us see the functional and non-functional one by one. Okay, the first thing is functional. It is checking the operation and action, what you are going to do with respect to the user requirement. Okay, file opening is there. Oh, it is there, but how much time the file opening is taking, that is non-functional. So functional is totally based on the business requirement. Non-functional is based on user or customer expectations, not requirement, expectation. Okay. The functional, here we are testing or checking the actual versus expected results that you also see in the test cases and test planning. Non-functional, the response, the speed, and these kind of other requirements, non-functional. Functional, normally we do manual. Non-functional, normally we automate it. Functional, test the functionality. Non-functional, test how the functionality is performed. How good, how bad, better, moderate. This is the non-functional way of testing. Okay. Testing the functionality is functional. How it is performing is non-functional. So eventually we come to functional defines what to test, and non-functional defines how to test. What is negative testing? How it is different from positive testing? So if you want to do a business, whenever you go to someone, you talk well. You talk in a good, say, language and easy. But when you go to fight someone, you will not start with, hey, you are not good, I am here to hit you. You won't say that. So this is how it is done in normal life. I'm not promoting that. But in positive testing, our intention is to prove that an application will work on given valid input data. That is, the testing is all about testing a system by giving its corresponding good valid inputs. So we are giving valid inputs and checking, okay, the system is working fine or not. What about negative testing? Here our intention is to prove that the application will not work when you are giving invalid inputs. This is the negative kind of testing. See here, in the negative testing, we are intentionally giving the invalid input and we are expecting an error. In positive testing, we are giving valid input and we are expecting the result. So negative testing is a technique that validates the system behaves gracefully whenever you input wrong. That is, if you even enter some bad data, invalid data, the system should give you a proper message, not an technical message like the abort or retry, so the user cannot understand. So there has to be a proper message and a graceful, you can say graceful falling of your software. So the user should know what has happened wrong. So this is negative testing. Now what is the positive testing? It validates that our system works as expected and compare the test result with the expected result. So most of the time scenarios for negative testing, they are also mentioned with in the functional requirement document. How do you ensure that your testing is complete and has good coverage? Now I'll just talk about certain books like Somerville and Pressman and RAJIB. They have said that testing is complete, never complete. Testing is never complete. The testing is just you take it off from your shoulder as a software team member and just put that testing job to the user. This is how you say it is complete. And this second discussion or second idea is that when your money is drained and your time is drained, then your testing is complete. This is how it is seen. So we are talking about actual completion and actual coverage. For that we need certain data structure or some certain matrices. So we have all the ifs, else and do, whiles, etc. All the conditional, logical, all the construct in our programming language, or you can say some algorithm or PDLs like procedure defined language. Now here we have the completion. We'll look at RTM. For good coverage, we'll look at the testing coverage matrices. So the RTM is all about the requirement traceability matrix, and the testing coverage matrix, this is going to help us to determine the good coverage that our test cases have actually covered all. So this requirement traceability matrix will help us to determine that the test conditions are enough so that all requirements are complete. So this traceability matrix is all about with the requirement, user requirement, the SRS, that user requirement have been fulfilled with respect to the test cases, that this test condition are enough to cover the requirement. Coverage matrix will help us to determine that the test cases are enough to satisfy all the identified test condition in the RTM, that is the requirement traceability matrix. So for the test coverage matrix, the input is RTM. Okay, for RTM the input is requirement specification. I hope you got the idea. For every requirement there are test cases, and for every test case there is total test coverage matrices, that all the coverage matrices is giving us that all the test cases which we are here to satisfy that all the identified test condition in the RTM we have done. For RTM, this is requirement traceability matrix, and the second one which you see is the test coverage matrices. Let me again tell you, for RTM, requirement specification is input. What are the different artifacts you refer to when you write the test cases? So whenever you are making a test case or writing a test case, what are you going to refer? There are different documents that you can refer. So this is a kind of test cases you are going to write. And for input, what do you want? First of all, software requirement specification. Then the use cases. If you are going for agile, user stories. And because the user is going to accept using the acceptance criteria, then acceptance criteria, that is going to be used. And the UAT, user acceptance test cases. So these all along with the functional requirement specification, requirement understanding of the document, these both are actually in SRS. The wireframes, and as I said, just user acceptance testing, acceptance criteria, user acceptance testing, you refer to these to make a test cases. Have you ever managed writing the test case without having any documents? The answer to this question will be yes. There are certain situations, there are cases when we have to write test cases without having any kind of supporting or concrete documents. So what is the best way? You can collaborate with the business analyst and development team. You can see the mail for certain information. You can see the older test cases and the regression suite if it is possible. If the feature is new, just you can go to different web content, wiki pages to understand that idea. You can sit with the developer, try to understand the changes being made, and based on all this understanding, you can identify the test condition, and then you can just make the test case with these inputs. This is another way also. See, when you have a code and you are maintaining it, what do? You don't have a supporting document. So you do the reverse engineering. From code, you try to find out the design. From design, you try to find out the requirement specification. This is you are doing RE, reverse engineering. And once you have a SRS, then you add the new requirement, then you design, and then you code. This is called the forward engineering. So you combine them, that is the total software re-engineering. But I'm just giving you an idea that this is possible. Test cases without documents are possible. What is meant by verification and validation? See, validation is that user wants say parrot, and you are providing him elephant. Is it good? Validation is this one. Validation is all about what user wants, user requirement. Let me just write a code. This is an add function. Now I'm writing an add function C equals A plus B. If you are getting a good result C as A plus B, then you have verified. But the user wants subtraction. You are giving him add. That is called validation. You have to check. So this is the main scenario which you are going to look at. Okay. So I'll give you one by one difference. Before that, validation is the process of evaluating the final product with respect to the software requirement specification and the business needs. The test execution which we do in our day-to-day life is the validation activity. We have smoke testing, functional testing, regression testing, system testing. This is validation. User wants this, we are giving him. If it is okay, validation is done. Verification is process of evaluating the intermediary work products in the SDLC, software development lifecycle. You'll have the design, the code. So we have to check that in the track Everything is being created properly so that we reach a final product. So you see the difference one by one. Verification is, are we implementing the system right? That is, we have made a good design, we have made a good specification. Validation is, you have made the specification, but have you made the specification for the right product? Verification is evaluating products of a development phase. Validation is evaluating products at the closing of the development process. Verification is, the objective is that verification, that is, we go to the requirements and design. Validation, user requirement. The verification, the activities are reviews, meetings, and inspection. Validation, we have black box testing, white box testing, and gray box testing. This is validation. Then we have verification, verifies that outputs are this according to the user input, the user requirements. Verifies the outputs are according to the inputs. Validation validates that the user accept the software or not. Okay. And the verification, it involves plans, requirement specification, design specification, code, etc. The test cases also. The validation, the items are evaluated. Actual product. This here we do the items are evaluated. Here the actual product of the software is evaluated, because this has to be given to the user. Verification, we do the manual checking of the documents and files. So we have different verification, reviews, meetings, and inspection for these. Validation, checking the developed products using the documents and file. Okay, this is validation. So have you made the right product? Have you made the product right? This is all verification and validation means. What are the different verification techniques you know? So because verification is mostly the static testing. So here static testing, we do reviews, and we can use different tools also. It can be informal, it can be formal. If you're talking about formal, then walkthrough, the technical reviews, and the inspection can be done. We'll just talk about these walkthrough, technical reviews, and inspection one by one. So as I said, verification is mostly static. There are 3 verification techniques, and here we do the review, inspection, and walkthrough, because we are verifying the work products. The review is the method by which the code test cases are examined by the individual, which is other than who has made it. It is one of the easy and best way to ensure the coverage and also the quality. So this is a simple review. It actually checks for quality also. Inspection is more technical, more disciplined in order to examine and correct the defects in the test, artifact, or code. Because it is quite disciplined, so we have certain roles in this inspection. We have the different people who are going, because it is called kind of a formal meeting. We inspect formally, and this is properly arranged and disciplined. And these are the names which you see here. See, people will sit. There will be a moderator, there will be recorder, reader, producer, reviewer. And walkthrough, this is a process in which the author of the document or code reads the content and just gives the feedback. This is mostly a kind of FYI, for your information session, rather than seeking the correction. So these are the 3 verification technique, static testing techniques. What is the difference between a load and stress testing? So one by one we'll see here. So load testing is, we validate the system behavior under the expected load. This is very important. Expected load. We know it and we are testing for it. The load can be of concurrent user or resource accessing the system at the same time. We are saying, okay, 1 million website user will be there, 1 million will be checking. This is load testing. But in stress testing, we are increasing it to say 10 million. Okay. That is, this is a testing technique which validates the behavior of the system when it executes under stress. That is, we reduce the sources and check the behavior of the system. For example, there is a chair, and one by one we break the legs of the chair and we try to see where it falls, on which leg. So we first understand the upper limit of the system and gradually reduce the resources and check the system behavior, and this is the stress testing. Okay. So let us see one by one. I hope you got the difference between these two. So load testing and stress testing, one by one. First of all, Load testing is finding the application behavior with expected load. You know the load and you're testing with that load, right? And stress testing is finding the application beyond that behavior beyond the expected load. What we know is load testing, but beyond that, stress testing. If the build is now stable, we can go for load testing. And now when the application is satisfying the load testing, then we go for the stress testing. Okay. So load testing, doing this test, we can validate the performance testing objectives. Okay. And stress testing, by doing this stress testing, we can find the breaking point of the application. Breaking, where it actually breaks. As I just suggested, a chair, we are breaking the legs. At what point the chair is going to fall. So load testing, we know the load, expected load, we do the testing with that load. Stress testing, we know the load, but we are going to exceed the load and see where the system or a software breaks down. And that is the limit we know. And most of the time the websites and this stress testing is used for them. In case you have doubts regarding any project, how do you approach? Now this is a very common sense type of question, but people ask it. If you have doubt, try to get it cleared reading the available artifacts, application help. In case of doubt, you can ask the supervisor, senior member, business analyst, you can ask the doubts, you can convey your queries to the development team, and the last option is you can go to the manager, his experience, finally the stakeholders. So anyone, because if you are not clear about the requirement, the doubts are not clear, nothing is going to happen. Have you used any automation tools? See, there are various tools. Some are proprietary, some are free, some does good activity for one job, some for other job. So this is the whole list of automation tools. Sahi Pro best for automatic reporting and bug logging. Vaate testing Wiz is there. Selenium best for web applications. Then we have the Visual Studio Test Professional, and then we have the Testcraft, and we have the Percy, Wonder Proxy. You just name it and we have it. So this is the different kind of automation tools we can use. Mostly if you're using Visual Studio. How do you determine which piece of software requires how much testing? For that, we need to know the cyclomatic complexity. The name itself shows it is complexity. So this technique of finding cyclomatic complexity, it is called McCabe cyclomatic complexity. It gives you three questions, answer for three questions. Is the program or software testable? Is the software understood by everyone? Is the software reliable? So the cyclomatic complexity gives the upper bound. I'll just tell you that this is a mathematical, you can say, way of computing the number of test cases you can. This is the highest number of test cases you can do, and then you know the test cases, and then you can go beyond that if you want, but this is the upper bound. So entire life cycle, if you know the code, or even if you know the flow chart, even if you know the PDL, the procedural defined language, or the algorithm. So cyclomatic complexity gives you the upper bound of the number of test cases you have to write. Okay, this is the one line answer. It gives you the complexity also, how much test cases you have to make, whether your software is complex or not. So let us take an example. Here is your you can say a basis path you have made, and now you have certain if else, certain do whiles, certain conditional and logical, all these things are happening. Don't go into the detail of that. I'll just give you the how to, there are ways to find out, three ways, and most of the time they'll come. I'm just saying that if you have number of instructions that are not doing any conditional or logical work, you can just combine them. So one node can be, say, having 100 instructions. So these are the edges and these are the nodes. And most of the time the nodes which we are interested in is about number of branching. So E minus n plus 2, edges minus node plus 2. In this example we have the edges number is 12, n is nodes are 8, 12 minus 8 plus 2 is 6. Second thing is predicate node. Predicate nodes are all those nodes which have more than two or more than two branches coming out of it. or nodes, these edges coming from it. So just count the predicate nodes and add 1 to it. And there is one more way. Count the number of regions. Region are the closed circuit which we are making. 1, this is 2, all these are closed. 3 and 4 and 5, and then we add one more which is the outside. That is also one region. So how many regions are there? 6. So every time we are getting the cyclomatic complexity as 6. Okay, this is all about this discussion. Thank you so much.